maybe we can maybe take a
tight feel.
sneak peek
Yeah.
here. Okay, Greg, I wanted to ask you about the safety of all of this, because I know that that's a big topic often, and I know that things are actually safe, but can you tell us about some of the challenges and how you guys make that happen?
So one of the great things that I love, so our company is a division of pneumatic and hydraulic, and we've been compressing gases for 65 years.
Right.
So my challenge of being relatively new to this company is I always say high pressure is 700 bar, 1,000 bar.
Okay.
To them, that's medium low pressure. So they've been doing pressurized gas systems far higher for quite a while. So
what kind of pressures has they been doing?
75,000 psi.
All right. And these are oil and gas applications?
A lot of oil and gas, some aerospace, and a lot of testing systems. So if someone wants to pressure test a tank or
so they've made that safe, so getting this lower levels, as you would call them, safe is not
and of course hydrogen has different properties that we need to pay attention to. We do a majority of our work early on has always been to study out all the different safety considerations, the different certifications and everything with that. Another thing that I really like is a lot of our systems, there's a lot of mechanical drivers in that, so a lot of backup systems, so it's not all maintained by a computer. And if there's an issue with that, there's a lot of inherent safety in the design.
So backup, okay. So I don't know, is there so if I want to make a hydrogen compression system safe, are there 3 things I need to do or something like that?
I think selecting the right components.
So components is one,
because even in a simple system like that, there's about 300 little bits and pieces.
Okay, all right.
So those are different failure points. So selecting the right components is really big. Making sure that you are the actual build out by people who are experienced and know how to properly cut tube and connect and everything with that. That was a challenge that I've run into before. We had people who were fantastic with hydrogen, great experience, but they didn't know how to bend tube and pipe and proper fittings. So sometimes it's working on that outside the hydrogen industry experience, people who are just experienced in high pressure gases. And I think the third thing would be to make sure that you have multiple points of backup. People talk about multiple points of failure, but you also want to have multiple points of backup. So if this valve fails or if this system fails, you have another backup system that can prevent something to be catastrophic.
So when you look at a system like this, what would be the backup that you would put here?
Yeah, so a lot of that's what's behind it.
Okay, what we don't see.
And you're welcome to see, and it's a pretty tight.
Maybe we can maybe take a sneak peek. So it's right in there.
Yep.
So what is I mean we got the basic gist of it, that it's coming in at lower pressure, but what would the backup system do? Would this open the valves, or would it let it out? So do you have an emergency
We have
outlet?
some vents too. So actually I can vent some right now, so you can see that pressure is dropping right now.
All right, okay.
So venting systems.
So this is now
it's
taking out the hydrogen that's in the system.
Outside. Yep.
All right, okay.
Yep.
That is to your piping which you have outside the building. All right, okay. So
we don't do any hydrogen venting indoors.
Okay. Good idea.
But again, this is still a prototype, kind of more of a proof of concept. So there's some things in here that we can have a bit more flexibility with. But a lot of times it's in isolating different parts of the system and making sure you always have proper venting.
Okay. So I guess that's another safety consideration there, and this was pretty mechanical. So if the electricity goes down on this, what happens?
Yeah, so that's another thing where it's good to have your mechanical systems. And then we have a mixture of solenoid valves that are, if they are so solenoid valves would be electrically controlled. We have a normally open valve, so if power goes off, then it's always going to be safe to vent.